Hello, it's Bill again. Today I'd like to talk about inflation. I'd shown a video in my playlist, The Observable Universe, to kind of show what happened after the Big Bang, but I want to cover that in greater detail because it's interesting. So in that particular video, we showed that as the universe keeps emitting gravity, the cosmic horizons get smaller and smaller, and each erasure from a cosmic horizon, each Planck area erasure, is paid back by a Hawking photon. And when these universes get very, very small from all of the gravity being emitted, then there's Hawking photons for each erased Planck area. So you can have, right now we have 10 to the 122 Planck areas in our horizon. And when that horizon is pretty much consumed by local gravity being emitted, it will be very small. And there will be 10 to the 122 Hawking photons into that tiny universe. So when this tiny universes get to around the size of 10 to the negative 18 meters, okay, about the size of a quark, that 10 to the 122 particles of that size sphere pack into a sphere that is about 1,000,000 light years across. So what happens is when the Big Bang happens, all the Hawking photons are condensed enough to where they're read as horizon area, and all the horizons expand at the same time, encoding every other particle. Every particle encodes every other on that 1,000,000 light year sphere packing arrangement. So that's the first expansion. Now space spreads apart during inflation. Now that every particle has encoded every other particle, the cosmic horizons start pulling the distant particles out first. And this was a very dense time in the universe when the information was extremely dense. So the information near the cosmic horizons moved across very fast. So this is why the universe expanded so fast in the early eras. And those particles that were newly encoded went back across the cosmic horizon and encoded those particle crossings as new horizon area, which reinflated the universe to the size we see today. We have about 10 to the 122 Planck areas on our cosmic horizon that was developed from particles that crossed from dark energy shortly after the Big Bang. So we had that first expansion where every particle encodes every other in that small sphere of about 1,000,000 light years. And then once every particle has every other particle encoded, then the horizons, remember cosmic horizons are the engines of dark energy. They're going to start pulling massive information across and inflating space, and that's why we have so much space today. Anyway, that's what I got for today. Watch my playlist, and thanks a lot.